right, hello Algebra 2 Advanced. Here are the 9.7 notes using trig identities. And what we're going to be doing is learning how to take a complex trig expression and turn it into a simple, usually one trig expression. And this is necessary for when you want to solve equations or when in calculus you're utilizing taking derivatives and integrals. I know that doesn't mean anything, but there is a reason for doing this, not just as some random exercise. So the first thing we want to talk about are some of the identities you're going to be using. So let's start off with your reciprocal identities. One of the strategies you're going to want to use when you're solving a trig expression or simplifying a trig expression or solving a trig identity is utilizing the reciprocal properties, where you can turn everything into sine or cosine, because some people are more comfortable with that. So remember, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Now, having said that, I do want to point out, whenever you see cosecant, I would not necessarily replace it with 1 over sine, especially if cosecant appears in the denominator of a fraction. So for instance, if I saw, say, cosine x over cosecant x, and I wanted to simplify that, well, cosine I would leave as it is. Cosecant, I'm not going to replace it with 1 over sine, because then you end up with a fraction over a fraction. The idea of a reciprocal is it just basically, if it's on top, the reciprocal function goes to the bottom. If it's on the bottom, the reciprocal function goes on top. So cosecant is going to become sine on top. So you don't have to then do the invert and multiply to simplify. Okay? So you have those reciprocal identities. You also have that tangent can be turned into sine over cosine. Cotangent can be turned into cosine over sine. Those are handy substitutions to make if you want to put everything in terms of sine and cosine. Then we have our Pythagorean identities. And I'm going to kind of derive these down below. Well, actually, I have a little space here, so maybe I'll do that. We know that if you had a unit circle, so we know that if there was the unit circle where the radius is 1, and I drew a triangle in here, so my hypotenuse is 1, this is x, this is y, we know that x squared plus y squared would equal 1. That's your Pythagorean theorem. Well, we also know in trig that the adjacent, which is your x, goes with cosine. So this could be replaced with cosine theta. The opposite, y, is your sine, so that can be replaced with sine squared theta. And so that gives us this first identity. Because it's addition, it doesn't matter whether you say sine squared plus cosine squared or cosine squared plus sine squared. It's the same identity. That's the main one to remember, because what you can do to get the other two is very simple. I'm going to give myself a little room and make this go away. If I had, if I had, like they have over there, sine squared theta plus cosine squared theta equals 1, and I don't remember the other two identities down here, you can quickly derive them by either dividing everything by sine squared, and notice what this gives me is 1 plus cotangent squared equals cosecant squared. That would be this identity. Or I could take my sine squared plus cosine squared. Let me write that out again. Sine squared theta plus cosine squared theta equals 1. I could also take each of those terms and divide by cosine squared. Cosine squared, cosine squared, cosine squared. And notice if I simplify that, that would give me, kind of ran out of room here, it would give me the tangent squared plus 1 equals secant squared. So the most important one to remember is sine squared plus cosine squared equals 1. The other two are really good to remember, but if you have a moment where you forget, just realize it's really easy to derive them. The other thing I want to say about these Pythagorean identities, because they're going to be used a lot, so it's the sooner you can kind of remember them, the better. But they will come to you in all different iterations. That I am going to write down below. So way down at the bottom of the page, if I had sine squared theta plus cosine squared theta equals 1, you might also see it like maybe we isolate sine squared theta. That would be 1 minus. It's the same identity. It's a relationship between those three terms. I might also see cosine squared theta equals 1 minus then sine squared theta. So the same would be true for the other two Pythagorean identities. In general, what I tell people is if you see something squared and then a 1, try and reference your Pythagorean identities, because most likely it will be one of those you can replace it with. Okay, let's kind of start in on this. Let's see how we're going to do it. So simplifying usually means you want to get it down to just one trig term. That's usually what your goal is. With simplifying, it's a little bit ambiguous because you don't always know exactly where you're headed. So what we're going to do in this example A is we're going to turn everything into sine and cosine. So that means that sine will stay as it is. Cotangent will become cotangent x. Oh, that was silly. Hello, it's the same thing. Cotangent is, whoops, cosine x over sine x. And secant x is going to become 1 over cosine x. And then we can see that sine will cancel with sine, cosine cancels with cosine. So it all simplifies out to 1, which is a much simpler term than sine times cotangent times secant. Okay, so that's one strategy. Turn everything into sine and cosine and see if you can cancel things out. Another common strategy, especially when you have two terms, so we have something plus something, and notice that you have a common trig in both terms. So what I would do is factor out your common factor, which is secant. That's going to leave me with tangent squared theta plus 1, your placeholder. Now, here's that mantra. Anytime you see something squared plus 1, check against your Pythagorean identities. So I'm going to have this secant stays as is. And then tangent squared plus 1 turns into secant squared theta. That's that middle Pythagorean identity. And again, I should be putting equal signs here. And then our last step, this would be secant cubed theta. And that would be it. You're done. Okay, so notice that every time I'm doing a transformation or a substitution, I'm writing it on a new line. So these are really about process. It's not about the final answer. It's about showing each step. So you don't want to do it all along one horizontal line. We are going to require every step that you do should be on a new line so that we can easily follow the process that you're showing. Now here in example C, this is going to be where you don't want to just substitute with a reciprocal, but use that concept of a reciprocal where the function goes to the other side of the fraction bar. So what I'm going to do is I'm going to draw myself one big fraction bar. And I'm going to do each one in a different color. So tangent, we know, is sine over cosine. And then we have cosecant, which we know is 1 over sine. So that means it's going to be written down here in the denominator. And then you have secant. Its reciprocal is cosine, so I'm going to write cosine in the numerator. So you're utilizing the reciprocal concept instead of being quite literal as just substituting it as one other. And so notice once again, everything cancels, and this would simplify to 1. They aren't all going to simplify to 1, but it does happen quite often. Okay, this fourth example, D, notice we have a product, and hopefully you notice that that's a difference, or that is, 1 minus cosine. Those are called conjugates. And when you multiply two conjugates together, because that's going to be a strategy that comes up later on, you get, so this is a minus b, a plus b, it gives you a difference of squares when you multiply those together. You're welcome to FOIL it out piece by piece, but you're going to find the middle terms cancel out. They're added and subtracted away. So this is going to give me the first term squared, which is 1, minus the second term squared, which is cosine squared. So I see something with a 1, something with cosine squared. If we look down here, notice that 1 minus cosine squared at the bottom of the page can be substituted with sine squared, and we're done. We've got it down to just one trig term. Okay, so conjugates will always work that way. And you'll find in the strategy, notice you multiply the conjugates, it gives you a difference of squares, which always will then turn into a Pythagorean identity. That's going to be a common theme. Then in this next example, again, notice we have two terms, but we have a common factor. So I'm going to factor out my cosine theta, which leaves me with 1 minus sine squared theta. And so then, if I look down at the bottom of the page here, I see that 1 minus sine squared can be replaced. So this can be replaced with cosine squared theta. And then since they're both cosine, I can put them both together, and that's going to be cosine cubed. All right, so we'll do a few more examples on the next page. So simplifying is actually a little harder than verifying the identities. This is really like proving an identity where you know the answer. And because of that, it's really important that you show each step on a new line, because it's not about the answer, it's about the process and showing that you use the logical identities to get to where you're going. The other thing about verifying an identity is you're only allowed to work on one side. Now, sometimes it's obvious which side to work on, and sometimes it doesn't matter which side. So to start off with, I'm going to work on this left-hand side because there's a lot more going on. That means that equals 1 is just going to sit over there. And I'm going to work with cosecant times cosine times tangent until I get 1. I don't ever touch the other side. You're only allowed to work on one side. So my strategy for this one will be to turn everything into sine and cosine. So cosecant becomes 1 over sine, and cosine just stays as it is, and tangent we know is sine x over cosine x, and then we see that, so this cancels with this cancels with this, that equals 1, and since these are the same, you're done. That's how you know you're done, when you get to that point where it's what you had on the other side. Okay? So this next example, again, I'm going to work on the side that has the cosecant times 1 minus sine squared, which means that my goal is to get to cotangent squared x. All right, so what do I want to do? Well, I'm sure some of you are going to take that cosecant and immediately turn it into sine squared x. And this 1 minus sine squared, that is one of your Pythagorean identities. That is actually cosine squared x. So that's my first step. Then I'm going to write this as a fraction with a numerator and a denominator, put them together. And we know that cosine squared over sine squared is cotangent squared, and since these two match up, that tells me I'm done. All right. Okay, let's keep moving on. In this next example, I could FOIL this out, but first, whenever you see something squared in 1, you want to test it against your Pythagorean identities. So I am going to work on this side. So my goal is to get minus tangent squared x. And so this right here has as an identity secant squared x. And before I do the next one, it is cosine squared and there is a 1, but be very, very careful because remember it's sine squared x equals 1 minus cosine squared x. So our signs are all off. My 1 is positive and negative in the actual identity. And so how do I deal with that? I'm going to multiply everything by -1. And now I know that this can get replaced with negative sine squared x. So you always want to like compare, but make sure, especially when there's the negative ones involved, because then order matters. Okay, so where do I go from here? Now I'm going to turn everything into sine and cosine. So secant squared is the same thing as 1 over cosine squared times negative sine squared x. Write that as 1 fraction here. And sine over cosine we know is tangent squared, and there's that negative that we needed to make those two the same. Okay? Whew. All right. Now we have secant x plus tan x equals cosine 1 minus sine. Now in class, I actually did this identity both ways because it doesn't matter sometimes which side you choose. And so just to be a little different, this time I'm going to work on this side. So our goal, I don't want to run into that other problem, I'm going to start it down here, is I'm going to leave this here. And I'm going to work on cosine x over 1 minus sine x, because this is an important strategy that I already kind of mentioned that you're going to want to use a lot. Anytime you see 1 minus a sine, 1 minus cosine, 1 minus tan, anything like that, there's no squared, so you can't use your Pythagorean identity yet. So what you do want to do is multiply by a conjugate. That's the strategy we're going to employ here. So I am going to multiply top and bottom by 1 plus sine x. All right, so what does that give me? Well, the numerator I am not going to distribute, and you'll see why in a minute. I almost never distribute that. The denominator, again, you get that conjugates. When you multiply conjugates, you get a difference of squares. So the first term squared minus the second term squared. And what happens is your numerator stays the same, but the denominator always will turn into a Pythagorean identity. 1 minus sine squared is cosine squared. So I can substitute the denominator. All right, so now what am I going to do? Well, this cosine will cancel with one of those, and I get 1 plus sine x over cosine x. So I have a fraction with what's called a singleton for the denominator. And so what I can do here is I'm going to do a common denominator backwards. So when you're adding two fractions, you bring together the two terms in the numerator with that common denominator. Well, if I go backwards, this turns into 1 over cosine x plus sine x over cosine x. It's sort of like distributing that cosine to those two terms. So that's sort of pre-common denominator. But now look at what we have. 1 over cosine is secant, sine over cosine is tangent, and that is what we were after. So we're done. All right, trig identities are one of my favorite things. They're just sort of manipulating and using the rules logically to transform something very complex into something very simple. And it is a really important skill, especially when you move on to like calculus and have to work with these trig expressions. You want it to be as simple as possible. The other strategy that was not really shown in these examples is anytime you're going from two terms to one term, the strategy you're going to use, how do you take two terms and make them together, is you're going to have to find a common denominator, okay? So you will want to be able to do that. There is a classwork with a few problems, and then you have a homework that also had a few problems on it, not very many. And feel free to let me know. I believe the answer keys are posted to check against your work, but I hope this made sense.